Hello students, welcome back once again. So today, this is our third video in the series, that is Diploma to Degree Exam Success Series for lateral entry students, that is the Masterclass. Today we are going to discuss one more topic, that is basic electronics, semiconductor, diodes and its characteristic. This is the third part. Again, I'm repeating, this is the third video in the series. So we will discuss about a part called diode and its characteristic. First, you need to understand what is semiconductor. So semiconductor material, neither it is a good conductor or it is a bad conductor. But you should every time say that as it comes in between that a good and the bad conductor, right? Or a good conductor, that is a conductor or a bad conductor. So there is a material, it's basically a material, which is silicon, germanium, gallium arsenide, indium phosphide. Now how you, from where this material, you can just go to the periodic table, which is on the right hand side, and you can see here silicon, germanium, this thing, and its atoms which are present in this, and you can just go for the decide the which band it stands for. Material, mainly it is silicon and germanium, and about where the silicon and germanium and about the atom and detailed studies, you can go for the bands. Okay, right. Okay, now we'll go to the next slide. Types of semiconductor. There are two types, intrinsic and extrinsic. Again, intrinsic and extrinsics. So intrinsics, what is the intrinsics? What you have to remember in intrinsic, it's a pure formation, pure form of silicon and germanium, the two materials we are discussing about. Extrinsic means when you make out two material, that is the main material. Suppose silicon we have taken. So from silicon, if you will add some impurities to it, that is some other impurities. What type of impurities it will be? It can be boron, some chemical, boron, gallium, phosphorus, arsenic. So you make a different type of material out of the main material. That is, we call it as, if the boron and gallium is added, we call it as a p-type material. You can see it here, p-type, which are the more of a positive, majority of the positive p-type this thing, and minority is negatives. Whereas n-type material, when you add phosphorus and arsenic into what you will add? Silicon. Okay, so that time you will get a negative n-type of semiconductor where the majority is minus. So two types, that is intrinsic and extrinsic. One more thing you have to remember, silicon above 0.65 or 0.7 acts as a conductor. Below 0.65, it is a non-conductor. Same thing, it will be there for the germanium. That is 0.25, precisely it is 0.3, and below 0. So it's a non-conductor. These points you have to remember. So here you can see that is silicon has 14 elements, that 14 electrons in it, and the germanium will be 32. Mainly today we see all the material, that is the diode and all, made up of silicon material only. Okay, let's go to the next slide. Now here on the top, you can see the characteristic chart. So we are discussing about diodes now and its characteristics. So characteristic chart, you should go through this chart and the symbol of the part called diode. Okay, where is anode and cathode? How does it look? What is the indication? What is the material inside it? Please remember, again, I'm telling you, it's a junction of P and N material. It is made from P and N material. One P and one N material. Okay, from here, from the chart, you can just make it out that 0.3 and 0.7 is the breakdown voltage, the germanium and silicon simultaneously. That is reverse breakdown and forward breakdown voltage. Now here, you please come down to the left and bottom chart. So diode symbol we have seen, there are different type of diodes, many type of diodes. So you should remember the different type of symbol, little difference. So like Zener diode will have different type of a symbol, whereas Schottky diode will have different, and rectified diode is a simple form of a symbol. Okay, so symbol is very, very important for you. You should remember it. Probably you may get one question based on this also. Now, what is the work of the diode? Switching is that is PN junction diode. Switching and rectification is the main work of the diode. Then there are other type of diode, that is Schottky diode. You can see here the Schottky diode symbol is a bit different. So where it is used, high speed switching, radio frequency, wherever we use a high speed radio frequency, and low loss rectifiers. Xeners, where do we use Xener type of diodes? Xener diodes, we call it as voltage regulator and safety circuits, right? Voltage regulators, that is regulation. Come to the right hand side, right? We have a photodiodes, we have a solar cells also. Please, right? Photometry, we call it the photometry auto light cameras. Okay, photodiodes, reverse current increases linearly. Okay, laser is also a type of a diode. In optical devices and disco lights, we use it. LED, I don't have to explain you. It gives you variety of colors and light. That is the only purpose. Okay, then you have other diodes also, tunnel diode and other different type of diodes. So mainly what I'm trying to tell you, you should remember different type of diodes, the anode and the cathode part. On the cathode part, some indication is provided and you should be able to identify. Okay, students, we will see in this video how to test a semiconductor diode. Okay, so you can see I have kept many this diodes over here, and few of the diodes are inside circuit. Okay, LED is also diode. This is Zener diode. For same type, you will get signal diode, detector diode. This is also diode, rectifier diode with a little thicker this thing. That means the ampere rating is more. This is also rectifier diode. So how to test a diode? So first of all, on the multimeter, you have to put the value or the selector switch to diode mode. Take the diode, right? You have two probes. Okay, just connect one probe and see what is the value. Nothing is coming. Okay, now what I will do is I will just reverse it. I'll put negative here, positive here and negative over here. I've got some value. Got it? Once again, I will show you. Reverse it, no value. Reverse it, you got value. If this is the case, that means your diode is okay. If both the side you are getting the value, your diode is short. Both the side you are not getting any value. Only value means when you are using an Ohm's range. Okay, you are not getting any value. The diode has open. Okay. Now let's come to our MCQ part. Choose the most appropriate answer for each of the question. What is the primary function? What is the primary function of a PN junction diode? That is the basic, very, very basic question. PN junction diode. Okay. So the answer is, out of A, B, C, D, the answer is to allow current flow in one direction only. That is the basic principle of a diode. PN junction diode, to allow current flow in one direction only. Let's jump to the second question. In a silicon PN junction diode under forward bias, the approximate voltage drop across the diode requires to start significantly conducting is, it is 0.7. Silicon is 0.7 and germanium is 0.3. The description I have given in the red color, you can see I have given the description so that you can go through it. Question number 3. The reverse saturation current in a PN junction diode is primarily due to the the correct option is minority carriers. Reverse saturation current is due to drift of a minority carriers, that are holes in the N side and electrons in the P side. We have just discussed about that across the junction. Okay, right. So next question, we will go to the next question. Question number 4. When a diode is reverse bias, the width of the depletion region, what happens to the width of the depletion region? So the correct answer out of this increases, the width increases. The applied reverse bias voltage adds to the built-in potential, pulling more charges away from the junction and widening the depletion region. That is the reason. Question number 5. The phenomenon where a reverse bias diode allows a sudden increase in sudden current and a specific voltage is called avalanche breakdown. Please remember, this is very typical. Forward bias, ohmic condition, diffusion. No, the answer is avalanche breakdown. It is a cumulative application of a charge carrying to collision, leading to a sharp increase in the reverse current. That is the phenomenon. Next question, that is question number 6. Which of the following material is most commonly used as a semiconductor in the construction of a diode? It's a very simple question. Silicon is the material that we are using. Right. Next question, that is question number 7. The VI characteristic. Here we come to the characteristic part. The VI characteristic of a PN junction diode is exponential, not linear, not hyperbolic, it is exponential. The reason I've given you, there is a calculation for that particular this thing. You can get a question like this. So please remember and calculate according to the given formula. Question number 8. What is the main cause of depletion region in a PN junction diode? What are the main cause? Diffusion of majority carrier across the junction. That is, the correct answer is C, diffusion of majority carrier across the junction. Why? When the P and N type of material are joined, holes diffuse from P side to N side and electrons from N side to P side, leaving behind immovable ions and creating the depletion region. That is the reason for it. Let's go to question number 9. A Zener diode is designed to operate predominantly in what direction? Is it forward? Is it reverse? Reverse bias at the breakdown region. That is the main purpose. Reverse bias at the breakdown region. Right? Don't write reverse bias breakdown below breakdown. It is a reverse bias at the breakdown region. So the correct answer is C. Zener diodes are specially designed to have a sharp and specific breakdown voltage, making them useful as voltage regulators. That is the reason. Finally, the last question, if an ideal diode is forward biased, it is treated as an open circuit voltage source. It is treated as short circuit, zero resistance. This is the correct answer. Very simple question. So these are the types of a question which will be there for this thing. So I'm just giving you a little idea to prepare yourself for this. You can just go through the slides I will be sharing with you and practice on this type of questions. Thank you for watching.